Hello everyone. So am I audible to all of you? So am I audible to all of you? Yes. Okay, fine. So let us. Yesterday we solved a numerical. Huh? We want that moment wala. So in that numerical, the depth was initially we considered what 0.08 because it was only up to that base course, right? Now in the second part, okay, the second part, look, dispersion of wheel load through wearing coat only. First one. The second one will be what? Dispersion of wheel load through wearing coat and structural slab. This will be the second part. Now here in dispersion of wheel load through wearing coat and structural slab part, how will you solve it? Okay, everything will be similar. Only one point will be different. Can you tell me which value will be different? I'm giving you a hint. This one, this 0.08 value is for what? Wearing coat. Now, if you see the question, so what will be the value here? I'm giving you that thing only. Tell me that value and which one will be different. Someone have to unmute and then speak up. Please.
That the value of u and v will change.
Uh-huh. Can you please be loud? Can you please be loud?
Hello, sir.
Yeah, I'm hearing. Tell me.
So I said the value of u and v will change.
The value
So
of the
u and v
U and V will
and
change.
m1.
U and V will change. Definitely U and V will change. Because of which value? Because of
So
which
that
value?
so the overall depth of slab now will be uh
Good.
200 plus 0.08. So we have to add that 200 plus 80 both the wearing coat and the structural slab.
Yeah. So what will be the new depth now?
So that's 0.28 meter.
Hmm.
That's
Good.
280 mm.
Yeah. Very good. Very good. So can you guys do now? The depth of slab will be 280 mm. Why? Look, if you see in the what do you call it question, it will be like this. It was like this. Initially, this was the wearing coat, and then this was the slab. Now this red part it was what 0.08, huh? And and this blue part, okay, this is the deck slab, right? This is 200. It is given in the question also. It is given in the question also, and it is given in the diagram also. So can you guys do it? Just tell me the values of u and v when u by v. Then this k will be same only. Okay, since capital B and capital L are same, so k will be same. Definitely k will be same. That is why we'll be having different small u and small v values. So the small u by capital B and small v by capital L. Okay, these two ratios basically will be different, right? So please try to solve it and tell me the answer. Are you guys able to solve the numerical? Are you trying? Those who are done completing, just send me the answers. Okay, I got only one answer. I need all answer. Someone's network is poor. Try to solve it. I got only one answer. I need more answers. So look, ignore this. There are some printing mistakes in this version. This will be how much? U equal to 0.5 plus 2 into 0.28. So it will come out to be 1.06. Okay, and V will be what? 0.25 plus 2 into 0.28. It will come out to be what? 0.41. Okay. Now small u by small b and small v by small l. So the small u, small b, small v by small l, you find out. Then you know the k. So then after that, you'll be finding out what? Using Pigeaud's curve, MB, capital MB and capital ML. Okay. So I think so. Someone get the answer. Yeah. So you found out till M1 and M2, but you'll have to find out till capital MB and capital ML. I'll give you 5 more minutes. Try solving it. I'll not show you the numerical. Just try solving it out. Please, everyone. Please find out capital M1. Find out capital M1 and capital M2. Okay, let us Go to the next topic. Design aids and tables for reinforced concrete bridge deck slabs. Now here, if you see, there are certain important parameters. Based on the width B and length L, following are the important parameters that are required to be considered for bridge elements. Now here the width B and length L of slab panel, number one. Number two, the type of support at slab edges, simply or fixed or continuous, whichever may be. Now you go to the three, which is the most important one. Type of loading. For type of loading such as 70R. Now in the type of loading class 70R, class AA and class A trade. We can consider what? We can consider uniformly what? Distributed load. Okay. Now the design tables. Okay, design tables are based on the following assumptions. The slab is analyzed as simply using elastic analysis with different boundary conditions. The dispersion of the wheel loads is taken up to the middle surface of the slab. The wheel core thickness is assumed as 75 mm and that of the structural slab as 150 mm. Just now we considered those as 80 and 200. Fine. In case of thickness greater than 150 mm, the values provided will be slightly on conservative side. Now, the bending moments are tabulated for two different cases which are commonly encountered on highway bridge decks. Number one, all edges are simply supported, and number two is what? All edges are either fixed or what? Continuous. Fine. Now, the variables which are considered on the slab are designated as follows. Number one, L, the length of the slab in the horizontal direction. B, width of the slab in transverse direction. Now, MXC and MYC are the positive moments that are developed in the slab. Then MXE and MYE, these are the negative moments that are developed. Now, the values of slab dimensions are as follows. The length L varies from 3 to 8 meter with increments of 0.25 meter. Okay. Then we have the width B. It varies from 1 to 5 meter with increments of 0.25 meter. Number C, the type of loading comprises of IRC class 70R, class AA, and class A. The key chart that indicates the plane dimensions of the text slab. Chart numbers varying from now you will have to consider about these design tables for finding out the moments from the slab dimensions. Now these tables, I guess I'm zooming it in. This is better take some screenshots. Okay. Please take screenshots of these tables. Table 3.6. Is it done? The screenshot taking done. Okay, good. Michael, good. You have given me the answers. But I expected some more answers. None of you are giving. You should give me answers. Because this is a numerical class and in numericals, the things should be more interactive. So once you are done taking the screenshot of this, I think so, we'll go to the next. Take a screenshot of this. might require these tables while solving numericals. Okay. Now the minimum reinforcement in slabs is that the tension reinforcement. That means the reinforcement in the tension side. It shall not be less than what 0.12% of the total cross sectional area while using Fe415 or Fe500 grade bars, and not less than, remember distance, and not less than 0.15% of the total cross section area when using Fe240 grade bars. Now for using cantilever slab, the minimum reinforcement of 4 numbers of 16 mm diameter HYSD bars shall be provided parallel to the free edge at 150 mm spacing. Okay, so this is what the minimum and the basic conditions that are required to be considered. Okay? I hope this is clear. We'll discuss this numerically in the next class. You can just write this given part, or you can just write this question. Okay, write this question. We'll discuss the numerical in the next class. Okay, this can be find out by using Pigot's curve. Okay, I've sent the PDF to someone of you. So did you get the Pigot's curve? The small m1 and small m2 can be found out by Pigot's curve. Did you get the Pigot's curve? Did you get the Pigot's curve? Let's see. I'm asking, yeah, okay. So if you open your pigeaud curve, look, we have to find out what in that question. We had to find out what, first of all, u and v. This u and v, okay, u and v came out to be 1.06 and 0.81. I hope this is clear. Now b you know 2, l you know 4. Now u by b ratio. In u by b ratio, you just find out u by b and what, v by l ratio. Now if you see here, the u by b ratio is 0.53 and v by l ratio is 0.202. Yes. Then what happens? This 0.5, u by b is 0.5, right? Now if u by b is 0.53, then this is what, 0.6. This is what is 0.6 for u by b, and this is v by l, right? Now this is 0.6. If this is 0.6, this is 0.4, 0.53 will be somewhere here. Yes. And 0.202. Now look, this is 0.2. Now 0.202 will be somewhere here, right? Now if you compare these two, it should be somewhere around here. So how much value did you get? Small m1, 0.138. Now for 0.138, look, 0.202 and 0.53. Now 0.53 will be somewhere here and 0.202 will be somewhere here. Now if you match here, now if you see the point where it is green color, somewhere here, the small one, this will be the point where this one and this one coincides, right? Then we are assuming this value to be 0. Then we are considering this value to be what, 0.138. Okay, so in this way what we are doing is we are getting the value of m1. Now how will it be m1? Because this one here will be what, this one here it will be 13 if you treat, or here they are interpolating and finding it out as 13 point what, 8. But if you see here, it is m1 into 100 is 13.8. That means what, m1 into 100 equal to what, 13.8. That means what, m1 is equal to 13.8 divided by what, 100. m1 will be what, 13.8 by 100. So we are getting it as 0.138. I think it is clear for you now. I hope it is clear for you now. Yes? Okay, good. Fine. Fine.
Hello, sir. Sir.
Yeah, yeah.
Sir, my name is Bangloy Konyak. Enrollment, I will
No problem. Don't
read
worry.
it through to the class one.
Don't worry. Don't worry.
Okay,
No
sir.
problem. 38, na?
Okay, sir. See you, sir.
Ah.
Yes, sir. 38, sir.
Don't worry.